Hey guys, we shall try to find step response of a LTI system. It's a causal LTI system with a difference equation given by something like this. Okay, and as we discussed in the previous video, what do you mean by step response? It is the response of a system. So if I have an LTI system, if the input is x of n and output is y of n and the impulse response is h of n, step response is nothing but response of a system y of n when the input x of n is unit step function. Okay, so it's a output from a system when the input is made unit step function. Okay, we shall try to solve this problem. Solution: we take directly Z transform on both sides. We have to take bilateral Z transform because there is no initial conditions here. So what is the Z transform of y of n? Y of z minus 3 by 4 into z power minus 1 y of z plus 1 by 8 into z power minus 2 y of z is equal to, since it's a step response, I have to substitute x of n as u of n, and what is this has to be u of n, and what is the Z transform of u of n? It is z divided by z minus 1. Okay, we will simplify this. Y of z I'll take common, 1 minus 3 by 4 z power minus 1 plus 1 by 8 z power minus 2 is equal to z divided by z minus 1. So y of z I retain in the left hand side. Right hand side I'll take this to the other side, 1 divided by 1 minus 3 by 4 z power minus 1 plus 1 by 8 z power minus 2. So I'll convert this to positive power of z. So I'll multiply numerator and denominator by z square. So I end up with y of z is equal to, numerator is z cube divided by denominator. So one pole is at z equal to 1 and the other two poles, since it's a second order system, so I get z minus 1 by 2, z minus 1 by 4. Okay. So what's the next step? I need to perform partial fraction expansion. So before that I have to bring it in the form of y of z by z, which is equal to z square divided by z minus 1 into z minus 1 by 2 into z minus 1 by 4, right? Okay, now y of z by z is equal to a divided by z minus 1 plus b divided by z minus 1 by 2 plus c divided by z minus 1 by 4. So where so I'm not solving a, b, c. I'll directly give you the result. A is 8 by 3, b is minus 2 and c is 1 by 3. Okay, now so if I plug these values here, what do I get? Y of z by z is equal to, so what is the value of a? It is 8 by 3 divided by z minus 1 minus 2 divided by z minus 1 by 2 plus 1 by 3 divided by z minus 1 by 4, right? Now if I take this z to the other side, what do I get? Y of z as 8 by 3 into z divided by z minus 1 minus 2 into z divided by z minus 1 by 2 plus 1 by 3 into z divided by z minus 1 by 4. Correct now? Now what is the next step? I'll write it here. So next step is to take inverse Z transform on both sides. So I have to take inverse Z transform for a causal sequence. By default system will be causal. So what is the inverse Z transform of y of z? It is y of n is equal to, what is this? 8 by 3 into u of n, because inverse Z transform of z divided by z minus 1 is u of n, minus 2 into, what is the inverse Z transform of this? A power n u of n, right? So u of n 1 by 2 power n u of n plus 1 by 3 into, so this is 1 by 4 power n u of n. So this is the step response of the system. Okay, so take it as a exercise problem and try to solve it. I'll give you the intermediate result and you just solve it and cross check it. The problem is a discrete time LTI system is given by h of z is this. It's a second order system. So I need to determine its impulse response for the following conditions. I need to determine the impulse response if the system is stable, and I have to find its impulse response if the system is causal. Okay, now what is the condition for a system to be stable? Its ROC contains the unit circle, right? And what is the condition for a system to be stable? Its ROC should be it should be outside the outermost circle, right? Okay, so solution, I think I have solved it in the previous problem, but still I'll give you the intermediate result. So after when I bring it into the form of h of z by z, so I get as 3z minus 4 divided by z minus 3 and z minus 1 by 2. Okay, So when I solve with the partial fraction expansion, I get value of A as 2 and value of B as 1, and the inverse transform and the impulse response for the first, that is system is stable, is given by 1 by 2 power n u of n minus 2 into 3 power n u of minus n minus 1. Okay, and the second one, impulse response for the causal system, it is given by h of n is equal to 1 by 2 power n u of n plus 2 into 3 power n u of n. This is the solution.